Hi, I'm Johnny, and I'm going to walk you through the project I and my team members worked on, which was optimizing LLMs for low resource language. My team members are Florid and Wilson, together with myself. The overview of the project was to see if we could reduce our large language models to a smaller size and still get a reasonable performance. And that this is particularly for translation, question answering, and sentimental analysis tasks. We had focused on Swahili and Hausa, which are the two predominant languages in Africa. People had previously worked on other methods to get a reduced model size or number of parameters. Some persons had tried out distillation, others had tried out quantization and pruning. For us, we had focused on distillation. These are a few samples of papers we had cherry picked that had tried to use distillation and had like some good results. Uh, we had sticked with the Incuba model, which was already having 400 million parameters, and this is actually a challenge that we decided to partake in. Um, our methodology we had, we're trying to see if we could reduce the parameter size from 400 to maybe something around 200, although for now it did not seem very efficient because of the performance of the model already on the already existing task. But the first thing we did was to see if we could reduce the vocabulary size from 61 to 32K. And our thought was, since the initial model was trained on 61K, it was because we had over five languages. Now, since we are moving to just two languages, we feel like a vocabulary size of 32 or a vocabulary size of even 16 may be efficient enough. Now, this is the result we had, and the difference wasn't so much on these examples we had tried to run on, and that was the reason why we still wanted to continue with this, just to see if this is the first step and is going to give us a good result. For the loss function for sentimental analysis, we decided to use cross entropy loss for question answering, cross entropy loss, and we also used for the translation task sequence loss. And then these had different classes, as you could see here. Uh, this is the distribution of the data set that was provided to us from the organizers of the competition. However, because the performance of the model wasn't too good as you could see here, we decided to uh, look for other data sets that would be able to use, and we're able to get a data set that has over 400,000 six sentences for Hausa and for the Swahili language, and we try to use that with a focus on the translation task. We had spent most of our time trying to see if we could improve the translation task performance, and you could see from this fine-tuned value, this is what we got when we fine-tuned it on the 400 samples. When we moved on to seek for different other methods that we could use to improve the performance, part of the methods includes for the semantic and question answering task. We sort of tried to see if we could use add an MLP layer to the existing model to see if that's going to help, and that actually helped us to get these results as opposed to what we previously had. Then we also try to consider the 32K vocabulary size and then train the model to see what the performance would be like. And this is sort of what we had uh, for the task. I think we made a mistake. This 2020, this 2712 was the performance we had on the translation task and not the semantic task. Yeah, this is further the result we got when we sort of try to distill the model. So instead of the eight layers that a model initially had, we reduced it to six. Same as the hidden size and other things like the intermediate size. And this actually gave us a reduced performance, reduced parameter size, as you could see here. And then when we now try to see what's going to be the character F score, you could see that the F score is quite low for this. This is we are still trying to train to see the full training result, what it's going to look like. We believe it's going to be better than what we have here. For the baseline, this is the result. And then when we use the 32K vocabulary size, while everything remains the same, the number of layers was 8 and thereabouts, we had this performance. Now, future work, we intend to focus on shrinking it a bit further, distilling it with chain of thoughts, and expanding the data set. Thank you.